Hi, Algebra 1 students, it's Mrs. Diff. I am going to be teaching you this particular lesson from my home. This is actually my little boy's schoolroom. We've got their art easel here to do the lesson on. If you'll notice, it's a little loved. I tried to clean it up a little bit, but it's still obviously a 7-year-old's art easel. I hope you won't mind. I decided it would be easiest to do the lesson that I missed in December on a video. That way I could send you all the video online, and with everybody's busy schedule, this gives you the opportunity to just watch it whenever it's most convenient for you, and to do the homework sometime in the coming week, so that when we meet together on Friday, next Friday, January the 9th, hopefully we won't have lost any ground and we can hit the ground running when we get back together. So if you have your week 14 packets with you, it would be helpful. I have mine here. Notice week 14, Algebra 1. Again, this is what we would have covered in class on the Friday before I was out of town. Notice it's kind of a light week, so this works out really well for us. It's not a really difficult week. Basically, we study section 5.6, which is the last section in chapter 5. So we're basically going to round out the chapter. There's a practice quiz, just 5 questions, and a chapter 5 review. These 3 items, as well as the graded homework page, which you'll notice is also quite light, only 5 problems. Those are the items I'm asking you to do and turn in to me on January the 9th, the first week that we meet together. It's not too much homework, and I think it's definitely manageable and will also help keep us on track. The only change I'm making to the syllabus is the chapter 5 test. Rather than asking you to complete that and turn that in on January 9th, I'm going to move that back to the following Friday, which would be January the 16th. And the reason for that is I know this video lesson is just a little out of the ordinary. You're all on break, and it's been quite a long break. And so I thought it was maybe a little unfair to ask you to take a test and have to turn it in the very first day we come back without giving you the opportunity to ask questions. So just to recap, for January 9th, here's what is due. Days 1, 2, and 3 from your from your week 14 syllabus. And then I'm moving the chapter 5 test back 1 week. So it will be due on the 16th. If you really feel comfortable with the material and you have the time and you just are feeling great about it, it's awesome if you take the test and turn it in on the 9th. I will certainly take it from you. But I just wanted to give those of you the option that might have questions or just need the extra time, perhaps you're traveling still with your families, to have 1 more week before the test is due. I thought that would be the best way to kind of keep us still moving forward, but make it fair and helpful for everybody. Okay, if you have your week 14 packet with you, if you could grab the notes, and also, along with the notes, if you could grab some blank notebook paper. Because what I'm going to do is start the lesson with a really simple, hopefully simple, overview of chapter 5, since it's been so long since we were together. So we'll go over the major concepts and some of the skills we learned before we left for the break. And so I'd like you to take notes on that, on just regular notebook paper. And then when we get into the new material, which is only 1 section, won't be too hard, I'll ask you to take out your notes and we'll follow along with those at the end of the lesson. And so once we cover all of that, you should be in good shape to do the 5-6 homework and the quiz, the review and a real simple graded homework sheet. Okay, so if you have notebook paper ready, I'll get started. Chapter 5 dealt primarily with slope, the slope of a line, slope-intercept form, and how to graph equations in slope-intercept form, and then how to use a little bit of flexibility, move an equation from slope-intercept form to standard form, and then back again, getting comfortable kind of going back and forth between those two common forms of an equation. Before we talk about slope a little more in depth, there's one concept that's really important to algebra, and it's particularly important to this lesson, so I just wanted to review it really quick. It's the concept of solving for. All right, you'll see those instructions on your math homework quite a bit. Solving for, solve for a variable. So, for example, you might get an equation that looks like this. 7x plus 3y equals 21. Okay, now here's the equation, and the instructions might say solve for x. All right, we've talked about this before, but what does that mean, solve for x? Up until now, as math students, normally when you're asked to solve for something, you're used to getting a whole number answer, like, well, x equals 5 or x equals 10. And in this case, we just have to shift our brain just a little bit, 'cause it's not really asking us to find a whole number answer. When you see the term solve for a variable, what it's really asking you to do in the case of equations like these is to take that variable, whether it's x or y or L, J, or T, and get that variable all by itself. Isolate the variable and move everything else to the other side. So in this case, because we were specifically asked to solve for x, that means we want x to become completely isolated, and we want to move everything that occupies the same side of the equation as x currently does over to the other side. So that means we need to get rid of the 7 and we need to get rid of the 3y. Now when I say get rid of, I'm not going to just make them disappear, but I'm going to have to cancel them out on this side and move them to the other side. Now how do I do that? Well, we remember the concept of inverses. There are operations in math that naturally cancel each other out. For example, adding and subtracting are opposite operations and they cancel each other out. Multiplication and division. Also, squaring a number and taking the square root, that same number, will cancel each other out. So, we're going to use the opposite inverses to cancel those values on this side and move them over. Now, we notice we got to get rid of 2. We need to cancel out the 7, and we also need to cancel out the 3y. Now, if we were in class together, I'd automatically be asking you, okay, which one do I want you to cancel out first? And hopefully one of you would raise your hand really quickly and say, the one all by itself, right? We always cancel out a value standing alone before we cancel out a number that forms the coefficient of the variable we're trying to isolate. So this value, because it's standing independent, it's kind of like a easy prey. It's easier to get rid of than the 7 currently is. And so we're going to cancel it out, move it over. Now right now 3y is positive. It's simply being added to 7x. So because it's being added, the opposite would be to subtract it. We're going to take negative 3y, and we're going to take negative 3y on the other side of the equation as well. Now why do we do that? Well, if we're going to do one operation to one side of the equation, we have to be careful to do the same operation to the other side. It's like balancing the seesaw, because right now we have a true equation and we don't want to change the value of the equation at all. We want it to stay constant throughout. So that's a rule in algebra. Whatever you do to one side, you have to do it to the other. So we subtracted 3y from one side, we're going to subtract 3y here. Go ahead and write the line to show we're going to drop everything down. Now so far we haven't changed 7x, so it drops down unchanged. Positive 3y and negative 3y canceled out. So we are left with an equal sign, and then I'm going to write 21 minus 3y. Now notice I kept them in opposite columns. I did not combine 21 and negative 3y into one term. The reason for that is they are not like terms. Remember, to be like, they have to have the same variable, and that variable has to be the same degree. So 21 is obviously a whole number. It doesn't have a variable at all. And negative 3y has a y. So it makes those two terms unlike. So they have to stay separate. They can be right next to each other, but they can't be combined into one term. All right, so here's what we have so far. We've gotten rid of one of the terms by moving it over. Now we can go ahead and cancel out the 7. 7 currently is being multiplied by x. So 7 is a factor. So if we're going to cancel it out, we want to use the opposite operation of multiplication, which is of course division. So we're going to divide both sides by 7. Notice that will cancel 7 out on this side of the equation, and that will leave us with, I'm going to erase a little bit up here, with a final answer of x equals 21 minus 3y over 7. Now, another way of writing this exact same answer would be x equals 21 over 7 minus 3y over 7. And in that case, it's a little bit easier to see how those fractions can be reduced just a bit. Notice 21 and 7. Well, that can be reduced easily into simply positive 3, or 3 over 1. And 3y over 7 obviously can't be reduced any farther, but it can stay in fraction form. So if you gave me this as your final answer, that's more than fine. This is just a more simplified version of the same. Okay, I wanted to go over that concept because in the concept of slope-intercept form, we know the standard equation is y equals mx plus b. And we'll go over what all of those terms mean. But notice it's y equals, and everything else on the other side of the equation, y is isolated. Y is on one side of the equation and everything else on the other. And that's the most useful form. However, your math book is not always going to be nice to you. It's not always going to give you the equation in its most useful form. Sometimes all the terms are a little messed up, and your job will be to first solve for y. Get y all by itself and everything else on the other side. And you follow the same steps that I just did here, and that's why I wanted to review it. Okay. So let's go over the concept of slope. Slope is really a measure of the steepness of a line. Now, we talked about this in class. You're used to looking at charts, looking at graphs, and based on what a line does, you have a general idea of what the data will do, or how it explains the data. For example, let's say we take a really simple first quadrant chart like that, and here along the x-axis we put the months of the year, and here along the y-axis we say do sales of some kind. I think in class we did cupcake sales or something like that. So I'll do that again. Cupcake sales. And let's say I have a cupcake business, and I looked through last year's data to see how my cupcake business did as I went from January to December. And perhaps I noticed that my sales start rather small, not too great, but as the months go, notice it's climbing. My business is getting quite good. As the month increases, so does my sales, and you'll notice that my line has a pretty even and, relatively speaking, steep slope. All right, what if my cupcake sales did something like this? Started off fairly high and then almost went down into a free fall as I went through the sales. Bottomed out to where I basically have nothing going into March, April, May. Now, from this graph, you can tell not only the line is quite steep, going in the opposite direction, but also that it's negative. So we're used to interpreting the steepness of a slope in lots of graphs already. You just might not have known it was necessarily called slope, but you've seen graphs like this before, I'm sure. All right, how do we find the slope of a line? There's a formula for that. The formula is y2 minus y1 over x2 minus x1. Now, if you remember from class, where you get these values are the 2 points supplied on the line. Remember, to find the slope of any line, no matter if it's positive, negative, horizontal, vertical, whatever it might be, in order to find the slope of any line, all you need to know are 2 points on that line. And you can plug them into slope formula and it will churn out the slope for you. So let's say we have 2 known points on a line. I have a couple examples here. Let's say one is at 7, 3. Remember, points on a line will always be given to you in ordered pairs because you need an x value and a y value. So one is at 7, 3, and the other is at -1, -5. All right, those are our 2 known points. What we're going to do is label and plug them into slope formula. So I'm going to label this as x1, y1, and this point as x2, y2. Go ahead and plug them into the correct spots in slope formula. So remember, I'm taking y2 minus y1, which is essentially the change in y, showing how much difference is there going up or down as I travel from point 1 to point 2. So if it's y2 minus y1, I'm going to take -5, and I'm going to subtract 3, which is my y1. And then for x2 minus x1, I'm going to take -1 and subtract 7. Give it an equal sign and we'll simplify. Let's simplify the numerator first. -5 minus 3 is -8. And -1 minus 7 is also -8. So if I have -8 over -8, a double negative will cancel out and become positive. And 8 over 8 can be simplified to simply 1. So the slope of that particular line is 1. All right. Slope-intercept form. Now this is the most common, most useful form of the equation of a linear line. And it's in this form: y equals mx plus b. All right, now we're used to seeing y and x in lots of equations, but what is the m and what is the b? Those two pieces of information are really important. M is the slope. So once we figure out what the slope of a line is, we're going to place it right there. It goes basically as the coefficient of x when you're in slope-intercept form. And b B stands for the y-intercept. The y-intercept is the place that your line crosses the y-axis. So if you remember, a Cartesian plane looks like this. This is the x-axis, and this is the y-axis. So if we turn our attention to the y-axis, this number here, depending on what it is, if it happens to be positive 2, let's say, positive 2 tells you that your graph is going to cross this y-axis at positive 2. So if you find positive 2 on the y-axis, let's say 1, 2, right there, and make a mark, you know that your line comes through your graph at that point. We don't know exactly what it looks like yet because we don't know the slope. It could come through at a positive slope and a fairly steep slope. It could come through as a negative or a very shallow, but we do know it crosses y at that particular place at positive 2. All right. Now we also know that if turn that back to B. If an equation is in slope-intercept form, we can graph it. Now we covered this in class, but I'm going to do just one of them in case you needed a little bit of review. Let's say I have an equation that looks like this. Y equals 3/4 x minus 3. All right, there's a pretty typical looking equation in slope-intercept form. Now this is a finished form of the equation. Remember, x and y will always be left as variables because they represent the myriad of ordered pairs that would make that equation true, all the different points on that line. So they stay as x and y. However, slope and the y-intercept are special to that line. So those are numbers you have to know before you can really have a finished form of the equation of a line. So it's in this form. It has all the information we need, and we can graph it. So I'm going to draw a little Cartesian plane here and just make a few indents for the positive and negative numbers. I'm going to do positive 1, 2, 3, 4, 5, 6, and then do it negative, and then positive on the y-axis, and negative on the y-axis. And if you have graph paper at home, of course your graphs will look just a little prettier than mine do on here, but you'll get the general idea. All right, when you're graphing a line, you have it in slope-intercept form. That means that you know the y-intercept is -3, and you also know that the slope is 3/4. You always graph the y-intercept first, all right? So -3, that means if we look at the y-axis and locate -3, -1, -2, -3, we know that our graph crosses the y-axis at this point. So we kind of use that as the base. Then from there, we calculate the slope. Now the slope is 3/4. That means that for every 4 units that I run or move in the x direction, at the same time, I'm going to rise 3. All right, it's always, that ratio is always the same, meaning that the rise is always over the run. If you ever get confused as to which one goes on top, think of it this way, that if something rises, it will always rise to the top. So rise is on top, run on the bottom. All right, I said that like 3 times in a row, sorry. Okay, so I'm going to use -3 as the base, and from here calculate the slope. I'm going to go over 4, 1, 2, 3, 4, and at the same time go up 3, 1, 2, 3, and make kind of a large dot, all right? So I plotted the y-intercept, and from there calculated the slope, and all I have to do then is connect the dots. I use a piece of paper just to make it a little prettier. All right, and And there's the graph of that line. It reflects both the y-intercept and the slope of that line. Notice it's a positive slope. It increases as you go left to right, and it's fairly shallow. It's not a super steep slope. Remember, a number here that's much higher, like let's say 5 or 6, relatively is much bigger than 3/4, would make that slope a lot steeper. It would climb a lot faster. Okay, so we know how to graph. The last time we met in class together, we studied how to take different types of information and write our own equations. So for example, a question on your graded homework from week 13 very likely asked you to do something like this. It's supplied the slope and 1 point. So perhaps the slope was 4, and a point on that particular line was at 1,9. All right, so in this case, you were asked to take this information and write your own equation. All right, I'm going to do one of them here just to review. We know we want it in slope-intercept form, so I'm going to go ahead and write the sort of bare bones version, y equals mx plus b. I know I need both the slope and the y-intercept in order to have a final answer. So, this particular problem, they were a little nicer to us because they gave us the slope. We're really not even asking us to do any work. They kind of just handed it to you and are simply asking you to know where the correct spot is to put it. And we know it goes right there. So we're halfway done. I'm going to rewrite the problem with y equals 4x plus b. Okay? Now, we still need to know the y-intercept. In that case, we're going to use the point that they supplied. That's one particular point on the line. And so that means that's one x value and one y value that make that equation true. So we can use that value for x and that value for y, plug them into our equation and solve for the one piece that we don't know, b. All right, so I'm going to switch up colors. I'm going to put y, which is 9, in for right here. And I'm going to take the value of 1, which we know is a true value for x, and plug it in there, plus b. Go through and simplify. 9 is equal to 4 times 1, 4, plus b. And remember, I'm still trying to figure out what b is, so I'm going to use inverses here. I'm going to subtract 4 from both sides to figure that out. And I have here that 5 is equal to b. So my y-intercept is 5. That was the other piece of the equation I didn't know, and now I know it. So if I go back to right here where I was writing my equation, my final answer, I know it's y equals 4x plus 5. And there's my final answer, all right? Now that's the easy way, right? They gave us the slope. They didn't really ask us to do much work. One version of the problem that you had on your homework that was just a tiny bit harder was this. They don't give you the slope, you have to find it yourself. But what they do give you is 2 points on the line. All right, so let's look at this problem here. We have 1 point at 1, 3, and another at -3, -5. All right, so you were given a problem like this on your homework, and you'll have it on the test, which is why we're going over it again. And you're asked to write your own version of the equation. So we know we want it in slope-intercept form. So I'm going to write that at the top. And I'm going to just kind of underline the 2 pieces of information we need to have in our final answer. All right, now notice they didn't just hand us the slope on a silver platter this time. They're going to make us work for it just a little bit. They gave us 2 points. Now remember, I told you that you can find the slope of any line using slope formula if you only know 2 points on the line. And so they supplied those for us. All we need to do is label and plug them into slope formula, and we'll be able to find the slope and plug it in for m on our equation. Okay, so I'm going to label this one as x1, y1, and the second one is x2, y2. By now you should have slope formula memorized. It's y2 minus y1 over x2 minus x1. So I'm going to go ahead and use it right here. I'm going to take y2, negative 5, minus y1, which is 3, put it over x2, which is negative 3, minus 1. All right, go ahead and go through and simplify. Let's do the numerator first. Negative 5 minus 3 is negative 8. Negative 3 minus 1 is negative 4. Notice the double negatives will cancel out, and 8 divided by 4 comes out to a nice even 2. So my slope is 2. I'm going to go ahead and erase that m and put a 2 there, because now I know half the answer. I'm almost done. All right, but remember I still need to know the y-intercept. So I'm going to use the same trick I used in the last problem. I'm going to use one of the points they supplied and plug it into my formula as one possible x and one possible y. And then the only variable left will be b, the y-intercept, and that's something I can solve for. When I have only one variable left, it's easy to solve, right? All right, so I could pick either point. I could decide to use 1, 3, plug it in, and I get the same value for b as I would get if I chose negative 3, negative 5. Again, you can test it on your own, and you'll see you get the same answer both ways. I always like to stick with the point that I think looks a little bit easier to work with. And in this case, 1 and 3 just looks easier to work with for me because there's no negative numbers. So that's what I'm going to go for. I'm going to plug 3 in for y, and I'm going to plug 1 in for x, and I'm going to go through and solve for b. So 3 equals 2 times 1 is 2 plus b. I'm trying to get b all by itself, so I'm going to subtract 2. And there's a nice easy problem. 1. So my answer for what is b, or what is the y-intercept, is 1. And I can go back up here to my equation. I already found the slope. I was looking for the y-intercept. I had to do a little bit of work, but I found it. So I'm going to plug it in right there. And there is my final answer. Y equals 2x plus 1. And notice it's in slope-intercept form, so if my problem asked me to, it'd be very easy to graph it in this form, because I can simply plot the y-intercept and calculate the slope from there, connect the dots, and I have a graph. All right, so that is basically what we learned in Chapter 5 before we went on the break. We have one more skill to master before you take the test. And so if you have your notes, you can open to page 1 of the notes. It's section 5-6. This is the last bit of new material before the end of the chapter. And it covers the concept of parallel lines and perpendicular lines. Now, these are two definitions I'm sure you already know, but just to review, parallel lines and perpendicular. All right, parallel lines look something like this. If you have a piece of notebook paper in front of you, all those blue horizontal lines on the notebook paper, obviously, those are parallel lines. So they might look something like this, or they could be vertical parallel lines, or they could have more of a distinguishable slope. But parallel lines are two lines that run next to each other and never intersect. They're in the same plane, but because they have the same slope, they will never intersect. No matter how far I were to follow this two lines in any direction, obviously they would never intersect, they would never cross because they have the same slope. Perpendicular lines, obviously, almost exactly the opposite scenario there. They do intersect, and not only do they intersect, but they intersect at right angles. So essentially they make like little plus signs wherever they intersect. If you're reading several math textbooks, will use like a shorthand version of the words parallel and perpendicular rather than writing them over and over again. So this little symbol where you take two, like a little miniature pair of parallel lines, that's just the little shorthand symbol for parallel. And then the shorthand symbol for perpendicular is an upside down T. So if you see that on a homework problem or in your math book, that's what that means. All right, now how can we apply this to writing our own equations? Well, here's how. Let's say I have a line at y equals 1/2 x plus 3. All right, and I'm going to graph that line. I do that by graphing the y-intercept first, which would be here at +3, 1, 2, 3. You can just kind of eyeball it. And the slope is 1/2. So that means for every 2 units I run, I'm going to rise 1 at the same time. So I'm going to go over 2, up 1. And connect those dots. All right, so there's the graph of y equals 1/2 x plus 3. Now, if I were to draw another line with the exact same slope, but just give it a different y-intercept, like let's say, for example, y equals 1/2 x minus 4. All right? Again, same slope, just a different y-intercept. So it's going to basically be the same line, it's just going to be dropped down on the graph. So if I were to graph this line, first I would plot a point at -4 on the y-axis, 1, 2, 3, 4. And then I would give it the exact same slope, over 2, up 1. All right, notice those two lines with the same slope create parallel lines. How could we use this in an equation? Let's say you get a problem that asks you to write an equation of a line. And one particular hint or one piece of information you're given is that it is parallel to another line. And they give you the graph or the equation for that one. Well, what you get to do in that case is essentially steal that slope. Because if your line is parallel to another line, you know they have the exact same slope, and you can take that slope from their line and plug it into your equation. And then all you'll have left to do is find B, or the y-intercept. So I'm going to show you what that would look like. Let's look at your notes, example 1. It says, write the slope-intercept form of an equation for the line that passes through a point at 4, -2 and is parallel to the graph of y equals 1/2 x minus 7. All right, so let's write the information they gave us here. They've told us that our line is going to be parallel to another line. And here's the equation of that other line. Y equals 1/2 x plus 7. Okay, so we know ours is going to be parallel to this one. And we also know that it passes through this point, 4, negative 2. All right? We need to write our own equation. We know it's going to be in slope-intercept form, y equals mx plus b. And we also know we need to know both the slope and the y-intercept in order to have a finished product, turn this equation as a final answer. All right, we're writing our own line, and we're told that it's parallel to this one. Well, we've already learned this. Parallel lines have the exact same slope. So if the slope of this line is 1/2, then the slope of our line is 1/2 as well. We basically steal that and plug it into slope spot on our line. It's as easy as that. That part's easy, right? Our equation isn't quite finished though. We still need to know the value for b. And that's why they gave us a point on the line. We needed that point on the line because we needed to know one x value and one y value that makes this equation true. So we can use that value for x and that value for y, plug it in, and then it'll be quite easy to solve for b. So let's do that. I'm going to take negative 2 and plug it in for y. And I'm going to take a value of 4 and plug it in for x. And go through, simplify, and solve. 1/2 times 4 is 2. I'm trying to get b all by itself, so I'm going to subtract 2. And negative 4 is equal to b. All right, so go back up here to where I was writing my own equation. I already know the slope, and I just figured out the y-intercept, so I'm going to replace that with negative 4. And there I have my final version of my equation. It's parallel to this line, it has the same slope, and it travels through this point, which is how I was able to find the y-intercept. All right? So you can use the concept of parallel lines to pull the information you need and write your own equation. Now, how can we use two lines that happen to be perpendicular to each other? It's almost as easy as parallel lines. There's just one extra thing you have to do, but it's nearly this simple. Now we know we know perpendicular lines intersect at right angles. So their slopes are not going to be exactly the same. Rather than being exactly the same, like parallel lines are, perpendicular lines have slopes that are opposite inverses of each other. That means this. Let's say you have one line with a slope of positive 4. All right? The slope of a line perpendicular to this one could be found simply by taking this number, flipping it, and applying the opposite sign. That's how you find a opposite inverse or a negative reciprocal. Two terms that mean exactly the same thing. So the slope of 4, if I want to be able to flip it, I probably want to write it over 1 because then it's much easier to flip. And I'm going to take it, flip it on its head, so now it's going to be 1/4. And because it started positive, in the new version of it, I'm going to apply the opposite sign, so it would be negative 1/4. These two values are negative opposite inverses of each other. If I were to multiply them by each other, they would have a product of -1, which is always true of two slopes of lines that are perpendicular to each other. All right, let's try another one. Let's say I had a line with a slope of -3/4. If I wanted to find the slope of a line perpendicular to this one, I would simply flip and switch it. So I'd flip it over to become 4/3, and now instead of being negative, the other slope would be positive. All right, so let's use this in an example problem. If you are following along on your notes, go all the way down to example 3. It says, write the slope-intercept form for an equation of a line that passes through, so we're given a point at 4, -1, and it's perpendicular to the graph of 7x minus 2y equals 3. Okay, so hopefully you're all noticing right away that this particular problem is making us do just a little bit extra work because they didn't give us the equation of the line in slope-intercept form. They're being a little mean to us. They're making us do a little more work. But remember, we studied this concept at the very beginning of class, and all we need to do is solve for y, and we'll be in slope-intercept form. Solve for y, of course, means to isolate y, get y all by itself. I need to cancel out the 7x, and I need to cancel out the -2. Remember, I'm going to cancel out the term that comes that stands on its own, that stands independently first. All right, so I'm going to subtract 7x from both sides. Cancels out there, leaving me with -2y is equal to, now again, these two terms are not alike, so I'm not going to combine them into one. And I'm going to get in the habit of always writing the x term first, because in slope-intercept form, that x term comes first with the slope attached to it. So it's just a good habit to get into. So I'm going to write this as -7x plus 3. All right, finally I need to cancel out the -2. I'll do that by dividing both sides by -2. So that's going to leave me with y equals, now I have -7 over -2x. I'll just write that out so that you can see that indeed the double negative would cancel. So this first part would actually become positive. And you can show that either by combining those and making a positive sign or simply just erasing the negatives. And then the -2 also gets divided into the +3, and there's not a double negative in this case, so it would stay negative here, plus 3 over -2, or simply -3/2 or -1.5. Okay, so they made us do a little bit of extra work to find our slope. They gave us an equation to use, but it wasn't in slope-intercept form. So we had to do a little bit of work first by simply rearranging the pieces a little and getting the equation in slope-intercept form. So what I'm going to do is erase some of this so that we have room, but write the equation there in the form that we can use it. So y equals 7/2x plus, or I should just make this negative, -3/2. Okay. All right, so now we're at a place where we can do the problem just like we did before. We are writing an equation of our own, and we want it to be in slope-intercept form. So I'm going to write slope-intercept form up here at the top. I know I need both the slope and the y-intercept in order to have a final version of my equation. In order to find the slope, remember my clue in this problem, if you read the problem again, says find the equation that passes through this point and is perpendicular to this line. All right, so the slope of this line is 7/2. If my line is going to be perpendicular to it, that means the slope of my line is going to be the negative reciprocal of this slope. So I'm going to take this slope, flip it, and switch the sign. That means my slope will be -2/7. All right, and that will create perpendicular lines. But I still need to know the y-intercept. Again, you use the point that they supplied. That's one possible x value and one possible y value that will make that equation true. Plug them into your equation. So -1 for y and 4 for x. Now notice we are going to get some fractional numbers here, which is kind of a headache. You just have to work with fractions. They're a little bit more cumbersome, but that's okay. We can do it. All right, so we're going to go through and simplify a little bit. -1 is equal to, if we're going to take -2/7 times 4, well, think of multiplying the numerators and multiplying the denominators. -2 times 4 is -8, and 7 times 1 is 7, plus b. All right, and then we're still trying to isolate b, so we're going to add 8/7 to both sides. I'm kind of running out of room here, and I apologize for that, but if you can see in little tiny handwriting, we're going to add 8/7 to both sides. And I'm going to do that kind of here on the margin, so it'll be a little easier to see. We're going to take -1, and I'm going to write it as over 1, because then they're both in fraction form. It's a little easier to add them, plus 8/7. Now remember, of course, in order to add fractions, you have to have common denominators. The least common multiple of 1 and 7 is 7. So we're going to have to make our denominator 7. I'm going to just draw a little line of partition here so we don't get confused with all the stuff over there. In order to write a new numerator, we need to multiply this number by the same number that we multiplied the 1 by. So 1 times 7 is, of course, 7, and -1 times 7 is -7. We don't have to make any changes here because we didn't change the denominator at the bottom. And we have -7 plus 8 is simply 1, and the denominator stays the same. All right, so the value for b is 1/7. That's our y-intercept, and that was the missing piece of the puzzle. That's what we still didn't know, so we're going to plug it in right there. And we have a final answer of y equals -2/7 x plus 1/7. All right, now I know that was a little bit cumbersome. That was probably one of the harder ones that you'll encounter just because the fractions made you have to add a few extra steps. But the concept is the same. If your lines are parallel, your two slopes will be exactly the same. If your two lines are perpendicular, your slopes will be negative inverses of each other. And in order to find b, y-intercept, you 9 times out of 10 are going to be using the point that they supplied as your possible x and y values. Plug them in and solve for b. All right, I think I'm going to conclude the lesson with that. That'll be the majority of your homework. And if you have any questions, please call or email me or just jot them down, and there'll be time to ask questions in class on Friday as well. But thank you for letting me do this video lesson and being flexible about it. I really appreciate it, and I'm looking forward to seeing you guys all in a week. Thanks. Bye.